What's up everybody? In this video, we are going to learn how to connect a slide switch to the Arduino and create an on-off switch using code. When the switch is on, the components in our circuit will work. When the switch is off, the components will not work. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our LED-push button with code circuit that we made in an earlier video. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to Slideswitch-on/off with code. Select a slide switch from the components and add it to the breadboard. The slide switch is also known as a single-pole, double-throw SPDT switch. A slide switch has 3 pins. If you hover over each one, you will see Terminal 1, Common, and Terminal 2. The common terminal is shared with both sides. When you move the switch to either side, you complete the connection to that terminal. The goal is to use the slide switch to make an on-off switch for our circuit. One side will be on or high, and the other side will be off or low. Start off by connecting the middle common terminal to pin 4 of the Arduino. Next, connect a black wire to ground and a red wire to power. Note that it does not matter which terminal is connected to ground or power, as long as they are connected to opposite values. Great! Now we will add code to read the value of the common terminal. If the switch is flipped to the side connected to power, we will read a high input value. If we flip the switch to the side connected to ground, we will read a low input value. Click on the Code tab and ensure the text drop-down is selected. Update the information in the header of our code. Update the program name and description. The program name is slideswitch-on/off with code, and the description is a sketch where we will read a digital switch input to turn on or off a circuit. Declare the variables for the switch. The first will hold the value of the Arduino pin connected to the switch. Type int switch pin equals 4 semicolon. Next, we will declare a variable to hold the state of the switch. Since it is digital, the state can only be a 0 or 1 or low or high. Type int switch state equals 0 semicolon. In the setup function of our code, we need to tell the Arduino that the switch will be an input. Add the line, pin mode, open bracket, switch pin, comma, input, close bracket, semicolon. Next, in our loop function, we will read the value of the input and print the value to the serial monitor. We will use the switch state variable to do this. Each time the program executes the loop, the value of switch state will change depending on the position of the switch. Type switch state equals digital read, open bracket, switch pin, close bracket, semicolon. Next, add serial.println, open bracket, switch state, close bracket, semicolon. This will print the value of switch state to the serial monitor so we can debug. Comment out all the other serial.println statements, so the only information that will print to our serial monitor is the value of our switch. Click Start Simulation and ensure the serial monitor is visible. If you move the switch towards the terminal connected to ground, you will see a 0. And if you move the terminal towards the terminal connected to power, you will see a 1. Great! We are reading a high value when the switch is on and a low value when the switch is off. Click Stop Simulation. Our on-off switch does not actually control power to the circuit. We are going to use the value of an input to control the execution of code. To do this, we will use a common control structure found in programming, a conditional statement. In a conditional statement, different actions can be executed depending on whether a condition evaluates to true or false. In the loop function, type if, open bracket, switch state equals 1, close bracket, open squiggly bracket, close squiggly bracket, else, open squiggly bracket, close squiggly bracket. What's going on here? We are telling our program to compare the value of the switch state variable to a known value. We know that if the switch is connected to power, the value will be 1. So if the switch state variable is equal to 1, the condition is true, and we will execute our program code. The else is used to execute separate code if the condition is false, or a value of 0. The code that will execute goes between the squiggly brackets. Since we only want our button and LED to work when the switch is on, cut and paste the code that controls our button and LED inside the squiggly brackets of the if, open bracket, switch state equals 1, close bracket. Last, add a serial.println, open bracket, open quotation mark, the switch is on, close quotation mark, close bracket, semicolon, inside the squiggly brackets of the if, open bracket, switch state equals 1, close bracket, and add a serial.println, open bracket, open quotation mark, the switch is off, close quotation mark, close bracket, semicolon, inside the else squiggly brackets. Click Start Simulation. When the switch is on, you will be able to press the button and turn on the LED. When the switch is off, you can press the button, but the LED will not light up. Our serial monitor will also indicate if the switch is on or off. Let's do one more thing. Remember that our button has a pull-down resistor? There is also something called a pull-up resistor. A pull-up resistor pulls a value to high, where a pull-down resistor pulls a value to low. Remove the wire that connects the slide switch to power. We now have a floating value when the switch is set to on. To enable the pull-up resistor, go to the setup function of your code. Change the value of input to input underscore pull-up for the switch. The Arduino has an internal 20 kilo ohm resistor, so we don't need to add one to the breadboard. Changing the pin mode from input to input underscore pull-up accesses the internal resistor. Click Start Simulation. You will see that the circuit works the same as it did before. This will help out when you build your physical circuits, as you only need 2 wires instead of 3. In your kit, you have another SPDT switch that looks a little different, the micro switch with an extended lever. It works the same way. You will notice a common terminal, labeled COM, and 2 terminals, one labeled NO for normally open, and one labeled NC for normally closed. Note that we can use the code from this tutorial to read the value of the SPDT lever switches too. Connect a wire from COM to an Arduino pin and use input underscore pull-up when setting the pin mode. Connect the normally open to ground. At the end of this video, you should have a better understanding of a slide switch, pull-up resistors, and conditional statements.